Hello everybody, welcome to our lesson on section 18F, where we're going to talk about integrating some more complex functions. Okay, so we're going to talk about doing an integration when we have a function of another function, okay, but specifically one where it's something times x plus something else, okay, where a is a coefficient and b is a constant. And in our textbook, we have this list of some more integral rules, okay? And notice that they're very similar to the ones that we learned before, except all of them have this 1 over a factor in the integral. That means in the original function, we had a coefficient of 1 over a if we want to end up with a derivative with no factor of a. And that's because if I take the integral, remember that I'm trying to find the original function. If I took the derivative of this function, say e to the ax plus b, I would have to take, remember that would be e to the ax plus b times the derivative of ax plus b, which would be a. But since I don't want an a in my final function, in the derivative, I'd have to divide out that factor. Okay, and when I do my integration, I'm always going to include that plus c to indicate that there could have been a constant that disappeared when we took the derivative. Okay, and you'll notice that's true for all of these. If I have a power like this, and I want to take the integral, remember that our power rule says we have to take this base, raise it to this power plus 1, and divide by n plus 1. But I also need to multiply by that 1 over a factor to account for the fact that when I take the derivative of this expression, there's going to be, I have to apply the chain rule. And so I'd have to take the derivative of this part in the brackets, which would leave me with a factor of a, and I want to divide that out to end up with just this simplified derivative. Okay, likewise, if I want to end up with a derivative that's 1 over ax plus b, well, if I take the derivative of ln of ax plus b, I'd get 1 over ax plus b. But then if I took the derivative of the inside part, I would have a factor of a that I need to divide out. Okay, if I want to end up with cosine of ax plus b, I would have to start with the function sine of ax plus b, but I'd have to divide out that 1 over a, multiply by 1 over a to divide out that a factor that I'd be left with when I did the chain rule. And likewise, if I want to end up with sine of ax plus b, I would have to divide out, I'd have to start with a negative cosine function, because the derivative of a cosine function is negative sine. So this negative would cancel out the negative from taking the derivative of cosine, and the 1 over a would cancel out the a I would get when I take the derivative of the inside. And again, notice all of them have this plus c to represent the constant. Now, here are a few examples I'll go through with you. Okay, now they're asking to find the indefinite integral. When we say indefinite, it means that this integral sign is just an integral sign. There's no boundaries. By the end of the week, we'll be talking about integrals with boundaries, and those are called definite integrals. It also means that we always have this plus c at the end because they are generic. They're not specific. We don't have enough information to find the actual specific function, but we have a lot of information to find most of the function. So if I started with something like 3x plus 1 to the 4, and I want to take the integral, so I wanted this to be my derivative, and I want to find the original function, remember that I would take this base, just like our power rule before, take this base, I would increase the exponent by 1 and divide by the exponent plus 1, but I also have to divide out this 3. That's why I'm multiplying by 1/3, because if I took the derivative of this function, that would be 5 times 3x plus 1 to the 4, and then the derivative of the inside part would be 3. And since I just want to end up with this 3x plus 1 to the 4 part in my derivative, I need to divide out the 5 and divide out the 3. Oops, sorry about that. Likewise, if I started with the integral of e to the 2x plus 5, following our rule, the integral would be e to the 2x plus 5, but I'd have to divide out this 2, and I would include my plus c. Okay, last, let's look at one more together. So we have the integral of 3 over 4x minus 2. One trick would be to rewrite this as 3 times 1 over 4x minus 2. Then I can bring that 3 outside of the integral sign. The integral of this would be ln of 4x minus 2 times 1/4, and that'd be multiplied by 3, and I'd have to include that plus c.